Okay, when we started talking about fractions, we talked about a numerator and a denominator. We said the denominator is the size of the piece, and the numerator is how many of those we have. So let's look at, for instance, fourths, and we have three of them. So this is 3/4. So I could think of one thing divided in four pieces, and then we take three of them. Okay? So that's 1 divided by 4 times 3, or 1 divided by 4 times 3. But there's another way we could do this. What if you took a stack of 3 cards? I'm just showing them one above the other, but you can just put them in a stack. Okay? And then say I cut these into 4 pieces. So I cut it in half, and then I cut each of these in half. Okay? So these are my cuts. And so if I'm taking 1/4 of 3, I'm taking 3 divided by 4, and I would get this. Notice that what I have are 3/4. Each one of these things is a fourth. I have 3 of them. So that's another way to see 3/4. I could see it as 1 divided by 4, and then I take 3 of them, or I could simply take 3 divided by 4. Okay? So I can see this fraction as simply a division problem. This means 3 divided by 4. Okay? So now, how do we change fractions to decimals? Let's try it. Let's take 3 and divide it by 4. And I'm going to put a decimal point and add a couple of zeros because 4 won't go evenly into 3. So let's bring the decimal straight up. That's the rule. So 4 won't go into 3, but 4 will go into 30. In fact, 4 times 7 is 28. If I subtract, I get 2. Okay? Bring down the next 0. 4 into 20 goes 5. 5 times 4 is 20. Subtract, I get 0. I get 0.75. So by taking 3/4 and treating it like a division problem that it is, and take 3 divided by 4, here's 3 divided by 4, and carry it out as a decimal, what you get is a decimal version of 3/4. So this and this are the same number in two different forms. Here's the form of a decimal, here's the form of a fraction. Okay? What if I take 1/3? Okay, let's take 1 divided by 3. 1 divided by 3. So 3 won't go into 1, so let's put a decimal point and add some zeros. Okay, how many times does 3 go into 10? Well, 3. 3 times 3 is 9. And I subtract, I get 1. Been there before. Let's bring in the 0. And here we have 3 into 10, just like up here we had 3 into 10. Goes 3 times. 3 times 3 is 9. Subtract, I get 1, just like before. Bring down another 0. 3 into 10 goes 3. 3 times 3 is 9. Subtract, I get a 1. If I add any more zeros, notice I keep bringing down another 0. I keep getting 3's up here, and I get 9's here, subtract, and I get remainders of 1 every time. So this is a process that will never end. So this is called an infinite repeating decimal. It's a decimal fraction that has a block of numbers, in this case just a single number, that repeats itself over and over and never ends. So one way to write that is to round it off and say, I want to round this off to the nearest tenth. This would be about 0.3. Or if I round it off to the nearest hundredth, it's about 0.33, something like that. And so you say that's close enough for your needs. If you need more precision, put another digit on there, 0.333. Okay? So when you divide the numerator by the denominator, take this number, divide it by that number like I did here, you're always, it turns out, going to get either a terminating decimal. That's like this. It's a decimal where you do the division and it comes to an end. You get to a 0 and you're done. That's a terminating decimal. You know, the Terminator, it brings things to an end. So a terminating decimal, it comes to a stop when you hit a 0 like this as a remainder. The other possibility is an infinite repeating decimal. Okay, so you'll always get one or the other of those two types. Let's try one more example. Let's try something like 3/11ths. Okay, let's divide 11 into 3. So if I take 11 and divide it into 3.00, let's put the decimal right above it. How many times does 11 go into 30? Well, 11 times 3 would be 33, so it won't go that many, but it'll go twice. So 2 times 11 is 22. Then I subtract. 8 and 2 is 10, and so we have 80 here. So bring down the 0. 11 into 80, well, 11 times 8 would be 88, so 11 times 7 would be 77. And you subtract and you get a 3. 7 and 3 is 10. If I carry the 1 to the bottom, it comes out like that. Bring down the 0. Look at this. We're back to a 30 again. 11 goes into 30 the same number of times it did last time. That'll be a 2. 2 times 11 is 22. If I subtract, I get an 8, just like before. So bring down the next 0, and here's an 80, just like before. 11 into 80 goes 7. 7 times 11 is 77, just like before. If I subtract, I get a 3, just like before. Bring down another 0, just like before, and so forth. This is going to go 2, 7, 2, 7, 2, 7, 2, 7, forever. So again, this is an infinite repeating decimal. It's not a single digit over and over like 0.33333, but there's a repeating block. So the 0.27272727 is going to repeat forever. Okay? So those are the possibilities. So when you take a fraction and you want to turn it to a decimal, there are times when it will divide evenly and you'll have a terminating decimal. That's like what happened when I took 3/4. Sometimes I'll have a repeating decimal where a single digit will repeat over and over again. And sometimes I'll have a repeating decimal where I have a block of digits that repeat over and over again. It's like you just made a rubber stamp out of this 2 and the 7 and go chunk, 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 chunk. You can just make copies of this over and over. And that's a repeating decimal. Okay? So that's how you do it. You take the numerator and you divide it by the denominator, because that's what a fraction means. The fraction means numerator divided by denominator. So if I do that, numerator divided by denominator, put the denominator out front and then divide, and what you get is the decimal version of the answer.